Cool. So I'm Lucas Thomeer. I'm actually a mechanical engineer, and I'll be talking about scar tissue and its effect on the soft palate after you've had a cleft palate repair surgery, or palatoplasty. So basically, just as an overview, the soft palate is located at the roof of your mouth at the very back, and it sort of dangles off the hard palate, which is that bony structure there. And you can actually touch the hard palate with your tongue if you put it on the roof of your mouth. And it's the purpose of the hard and soft palate is to separate your oral and nasal cavity. And this is important for things like speaking and like blowing or anything like that, where you need to like create pressure in your mouth. And there's actually mostly one big muscle that runs through the soft palate. It would be going into the plane like this, and it just sort of pulls back, and it takes the soft palate and it presses against the back wall of your throat, which then creates a seal, so that you can do a lot of different things. So for instance, this is a dynamic MRI I took last summer of a subject saying "buh, buh, buh." And if you look at the soft palate during this, it's moving back and forth the whole time, and just sound. And just the entire time you're speaking, it's moving all over the place. So a cleft palate is it's a birth defect, and it's just when you have a gap or a hole in your palate so that the oral and nasal cavities are always connected. And it creates a lot of problems, especially with feeding as a baby. And then it occurs in about 1 in 700 live births in the US, and it's the most common birth defect in the US. And because it's so common, there are actually a lot of surgeries around to fix it, with the von Langenbeck there being from the 1850s, it's the original one, and since then there's been a lot. But they're all relatively unsuccessful, with most, like about 25% having lasting deficiencies, or you need like another surgery or something like that. And this is mostly because it's a very complicated, non-intuitive system that's really hard for a surgeon to sort of grasp when they're like in the back of like a 9-month-old baby's mouth. They're trying to figure everything out. So for my project, I looked at furthering the understanding of the mechanics of this system, specifically as it related to scar tissue and how that affects the movement of a soft palate after you've had a surgery. So this is the model I created. This is a finite element model. And just to sort of get oriented on the anatomy going on here, this purple piece dangling down is your soft palate, and it would be grounded to the hard palate, the bony structure up at the front there. And then on the back, that blue piece, the posterior pharyngeal wall, is really just the back wall of your throat, and that's what it's pressing up against to create the seal. And the green piece, the levator villi palantini, is that main sling muscle, and that's what's going to pull it back. So when I run the model, the input into the system is that levator muscle contracting, and the output is going to be the amount of force it pushes on that back wall with the closure force. So that model had no scarring in it, so to actually get real useful data, I had to like put scar patterns into it. So I chose 4 surgeries. The 3 of them, the von Langenbeck, the VY pushback, and the furlough, are the 3 most commonly used surgeries today, and the Wu is a newer surgery that I think shows promise, so I threw it in to see. And so I went through a lot of literature and sort of mapped out the scar patterns that mapped out the scar patterns for each of them, and then put them into the model. And then I changed the data so it was scar tissue and not regular tissue. It had different material properties, and I ran all of these simulations, and I got muscle activation versus closure force. And so this is the final graph that was really the conclusion of this whole thing. And to sort of get oriented on this, on the x-axis, you have maximum contraction, or percent maximum contraction, which is just how much you're contracting that muscle. And then closure force is how much the soft palate's pushing on the back wall with. So this is just the normal, no scar tissue line. And you'll notice thing to like note on it is the point where it lifts off that like bottom axis is when it first contacts that back wall. And that's going to be the lowest amount of contraction you can do to possibly get a seal. And that's important for it to be lower because when you're talking, your palate's always moving. And so if it takes you a lot more effort to like get that seal initially created, you're going to fatigue really quickly, which is a common problem among cleft palate repair patients, that they fatigue really quickly when they talk for a while. And then so now the palatoplasties that were tested, and the first thing you'll notice about this is that they are all significantly worse than normal. So just like any sort of scar or scar tissue is already going to drop down the amount of closure force you can create a lot. Additional notes, the Wu performed the best among all of them. And also, this sort of surprised me. So my initial thought was just the least amount of scar tissue possible is better, so like the lowest volume of scar tissue, but the Wu actually has the most scar tissue. It's a very complicated surgery. The furlough probably has a second, and the von Langenbeck and the VY are similar, and they have very little scar tissue. They just really have one incision. And like, that didn't really affect it as much. The bigger conclusion was just where the placement of the scar tissue mattered a lot more than the amount of it. Just to reiterate some conclusions, scar tissue matters. I think the Wu shows promise in that nobody really does it right now because it's so new and only one guy even knows how to do it, but it warrants like further investigation and like a bigger clinical trial. And placement of scar tissue matters more than volume. And then going into the future on this project, I'd like to, if you notice, it was a half model, which is okay for the most part because it's a metric system, but I'd like to take it and create it into a full model just to like cover all my bases. And also, I had to create a material model for the scar tissue, which is a little weird because they don't have human data for your soft palate scar tissue. So I had to like make some assumptions there, and I would like to like do a sensitivity like test and adjust that value to then tell if it's valid or not. Thank you.